This is a video to demonstrate how to work with the version of FRCcalc 2.0.0 to design and analyze a fiber-reinforced concrete structural member at the cross-section level according to the design recommendations and guidelines of the FIB Model Code 2010. The main interface window is organized in 4 different window tabs: the geometry and type of analysis, the FRC and concrete data material, the longitudinal steel reinforcements, and the transverse steel reinforcements. In the first window tab, the user must provide information of the following data: the type of element to be analyzed, the dimensions of the cross-sections. After inputting the cross-section dimensions, a representative figure of the cross-sections is created and displayed. Next, the user must select one of the options regarding the type of cross-section to be analyzed. It is possible to analyze a cross-section of a fiber-reinforced concrete structural member, FRC, or a reinforced concrete member, RC, without fiber reinforcements, or to perform a comparative analysis between FRC and RC cross-sections. Next, the user must select the type of analysis to be performed. In FRCcalc are available the following analyses for FRC and RC cross-sections: determine the ultimate flexural capacity of the cross-sections, determine the ultimate shear capacity, evaluate the design crack width, and evaluate the stress limitation criteria. Let's start by comparing the ultimate flexural capacity of FRC and RC cross-sections. The user must input the design value of the axial load for the ultimate limit state analysis. Let's consider that the axial load is equal to 0. In order to analyze the flexural behavior of an FRC cross-section, it is necessary to supply the data to evaluate the structural characteristic length. Let's consider that the type of loading is equal to long-term and repeated loading, and the cracking state corresponds to a stabilized cracking stage. For the load combination corresponding to the cracking serviceability service state, the axial load is equal to 0, and the bending moment is equal to 60 kN/m. Next, in the FRC concrete window tab, the user must supply the material data information. The user can select a concrete strength class to define the concrete mechanical data. Let's consider C4050. The concrete mechanical parameters can be edited by checking the boxes in the vicinity of each parameter. The characteristic values of the post-cracking residual flexural strength of the FRC are input in these fields. The partial safety factors for concrete and compression, in tension, and in shear can be edited in these fields. Next, the user can add conventional longitudinal steel reinforcements to each type of cross-section. It is possible to add 2 layers of bottom and top steel reinforcements for each type of cross-section. The bottom layers corresponding to the tensile reinforcements, and the top layers correspond to the compressive reinforcements. Let's consider that the FRC cross-section has the following type of tensile reinforcements. After inputting the information regarding the reinforcement, it is displayed an illustration of the arrangement of the reinforcements in the cross-section. Let's consider that the RC cross-section has the same type of reinforcement as the FRC cross-section. User can introduce the information manually or can use the following button to copy the reinforcements of the FRC to the RC cross-section. To analyze the flexural capacity of the cross-section, the user can start the calculation by clicking the Calculate button. After calculation is concluded, the user is redirected to the Results window tab. In this window are presented the results regarding the determination of the structural characteristic length of the FRC cross-section and the results of the ultimate flexural capacity of FRC and RC cross-sections. In addition, is presented the moment versus curvature relationship at the ultimate limit states for both cross-sections. Next, let's demonstrate an example to determine the shear capacity of a cross-section. Let's return to the first window tab and select the boxes corresponding to the shear analysis. Now the user must define the values of the axial and shear forces and bending moments acting in the control section of the structural member. For the shear analysis, it is also necessary to define the maximum size of the aggregates of the concrete. And the characteristic values for FR2 and FR4 are also prompted to be inputted. Now let's define the conventional shear reinforcement for both cross-sections. The user must define the information regarding the type and distribution of shear reinforcement in the structural member. After inputting the data of the transverse reinforcement, it is displayed an illustration of the shear reinforcement arrangement in the cross-section. Let's proceed with the analysis. The user can check the results of the shear analysis for both FRC and RC cross-sections. In FRCcalc are considered both shear models for FRC members presented in Model Code 2010, the model based on the simplified modified compression field theory, and the empirical model. Now let's demonstrate the analysis regarding cracking control. Let's return to the Window tab to edit the type of analysis to be performed. Let's check on the box corresponding to the cracking control. The data necessary to perform the analysis of cracking control were already inputted to determine the structural characteristic length. After clicking Calculate, the user can check the results regarding the moment versus crack width relationship for both cross-sections, and the crack width and mean crack spacing for load combination corresponding to the serviceability limit state. Next, let's evaluate the stress limitation requirements for FRC and RC cross-sections. Let's return to the first window tab and check the stress limitation boxes. The user must provide the actions on the cross-section for the characteristic and quasi-permanent load combinations. Let's click in Calculate and check the results regarding the verifications of the stress limitation criteria. After performing any analysis, the user can export the results to an Excel template file by clicking in Export to Excel button.